So we'll be looking at three problems from Emil Agarwal, 29 of exercise 5, 29, 30 and 31. Now the first problem states that we have this inequation which combines two different inequations, this one and then this one. So what we do first is we divide this complete inequation as two different inequations, taking this part as one and the second one as the other. So considering this part, we get 13x minus 5 is less than 15x plus 4. So we take the x terms to one side and the constant terms to the other. So that becomes minus 4, plus 4 becomes minus 4, and 13x becomes minus 13x. So we get 2x here and we get minus 9 here. As you can see, 2x will be greater than minus 9, and therefore x will be greater than minus 4.5 by dividing both sides by 2. Similarly, if we solve the second part of the whole inequation, again take the x terms to one side and the constant terms to the other, then we find 15x minus 7x and 12 minus 4x. So this becomes 8x and this becomes 8. So 8x is less than 8 and x is less than 1, dividing both sides by 8. Now both of these inequations are two different parts of the original combined inequation. So for x to satisfy this whole condition, these two conditions have to be, like this condition and this condition, both have to be satisfied simultaneously. So you take the intersection of both these conditions. So we have x being less than 1 and then x being greater than minus 4.5, and x is a real number since x belongs to R. So if you take the intersection, we'll see that it will go from minus 4.5 till 1. So we write it as a set builder form, since we cannot write all the real numbers from minus 4.5 to 1. And similarly, we draw the number line. Now in the number line, since it's a case of real numbers, you cannot point out each number, so you'll have to darken out the line, the part of the number line which contains all the numbers. And since both of these conditions are less than and not less than equal to, we put these two numbers as hollow circles. If it would have been greater than equal to and less than equal to, then these would have been complete darkened circles, not hollow circles. So that's about that. And on to the second question. We have similar type of question where again we have a combined inequation. Again we'll divide it into two parts. The first part being, I've written 2.5 as 2.5. So minus 2.5 plus 2x is less than 4x by 3. Again we do the same process. Basically it's quite simple. We take the x terms to one side, 2x minus 4x by 3, that gives us 6x minus 4x, that is 2x. So 2x by 3 minus 2.5 becomes plus 2.5. So 2x by 3 is less than equal to 2.5. We take this to the other side, so it's x less than equal to 2.5 multiplied by 3 divided by 2. That gives us 3.75. And similarly we solve the other part. So 4x by 3 is less than equal to 4 by 3 plus 2x. Again bring this 4x by 3 to this side and 4 by 3 to this side. Then we get 2x minus 4x by 3, which is again 2x by 3, and this side we have minus 4 by 3. And obviously since we are taking this x terms to this side, it will become 2x by 3 is greater than equal to minus 4 by 3. Both 3's get cancelled on each side. We divide both sides by 2, we get x greater than equal to minus 2. Again, similarly to the previous question, we take the intersection of both these two inequations. So we'll again find a situation similar to the previous one, where we have x greater than minus 2 and x less than 3.75. The only difference here being that earlier we had x belonging to a set of real numbers. Now we have x belonging to a set of whole numbers, denoted by this w here. So all of you know that whole numbers are obviously like 0 to infinity, excluding any decimal numbers. So we only have so like minus 2 and minus 1 won't be included here. So we'll start from 0 and we'll go up to 3, since we cannot include 3.75 or any number greater than 3 but less than 4. So we have 0, 1, 2 and 3. That's all we have in the solution set, and we can simply denote it in the number line by pointing out these 3 points, these 4 points. And the last question we have done here is again very similar, only difference here again being that we have the set of integers here, the x, that is x belonging to the set of integers. So we again solve the whole combined inequation by dividing into 2 different parts. And so we have 2x minus 5 is less than equal to 5x plus 4 from this part. So again you bring all the x terms to one side, so 2x goes here, it becomes 5x minus 2x, 4 comes here, minus 5 is already here, so minus 5 minus 4, we have 3x from here and minus 9 from here, it's 3x greater than equal to minus 9. Now you can do this either way, you can take 5x to this side also, it will be giving you the same answer, it does not matter. Similarly, we solve this part, the other part of the combined inequation, we get 5x plus 4 is less than 11, so we take 4 to this side, and we have 5x less than 11 minus 4, which is 7. Dividing both sides by 5, we have x equal to 1.4, sorry, x less than 1.4. So again, like all the other questions, you take the intersection of these two conditions of these two inequations. So you have x starting from minus 3 and going up to 1.4, but it's belonging to the integers. So now unlike the previous question, we can include these negative numbers because x is belonging to integers. So we have minus 3, we have minus 2, we have minus 1. We are including minus 3 since it's greater than equal to, and then we have 0, and you can see that x is less than 1.4, so we can only go up to 1 and not beyond that. And since it's integers, we are not including any decimal numbers. Again, once you write the solution set, you can simply just mark those numbers since these are integers on the number line, and voila, you got the answer.